I needed to mount the fan. And so I did drill some tap size holes for M3 by 0.5. And I decided I for people that don't have a tap or don't have a tap and matching drill, just drill 4 holes. Now, about 15 years ago, I got my first pacemaker, open heart surgery. And it turns out that they tied my breastbone back together with a piece of stiff wire, heavier than this, and did what the doctor called a bread bag twist. Well, about 2 months ago, this end of the twist began poking through my chest, through the flesh, through the skin, I guess. I had seen this tie and the wire on an x-ray. Had I been able to see it before I was operated on, I'd changed doctors. Not that the wrap-around wire or the twisted ends were a bad idea, but he didn't tuck them in. He just left them sticking up. If you drill 4 holes, this is a Cat 5 wire. Cat 5 cables that, you know, if you hunt around for it, you can find it extremely inexpensive or even free. And just wrapped and twisted. I did solder it because I thought, what the hell. There, the fan's secured. Inside me, it lasted 15 years. I took the schematic and the parts placement drawings and added these voltage measuring points. There's 14 of them scattered throughout the circuit. They're all referenced to here. So I would install this end of this diode a little bit high. If I install it perfectly flush, and it's hard to get a clip lead on there. Anyway, all of these nut measurements, the voltage measurements on all these points, I have the negative lead referenced here. And while I was making a chart for troubleshooting purposes, you can see I measured the transformer voltage under different conditions: no load, half amp, 1 amp, and so on. I measured all 14 points. I also measured the output voltage. Well, the transformer voltage started at 28.5 and at 1 amp went down to 24.5, 24.4 volts. However, the output voltage went from 29 down to 18. So I just went ahead and rigged up an LM317, a bridge rectifier and capacitor, a voltage potentiometer, it's 5K, and a couple of other 220 ohm resistors. So I installed and powered the lines in purple. So I didn't install anything here. Didn't install these things or this. I didn't even install this capacitor. I put in the 5K resistor, one of these 220 ohm resistors. This one probably could have been shorted out. This one is necessary. I put the diode in and the capacitors and diodes. Just a bare 317, 220 ohm resistor between just and out, and then a 5K pot. So, but I can't adjust it to 0 because of this 220 ohm resistor. Okay, that's all right. And here's the bare 317 circuit. Maximum output is 31.7 compared to 29. For the completed board now. Under a 1 amp load, it drops to 27.3. Well, remember the transformer dropped 4 volts here. From 28.8, well, say 4.5 volts even. The bare circuit, the output dropped from 31.7 to 27.3. I think that all of these components that I did not use are limiting the output of this in any event. Now I have taken the heatsink off, but this board was rated at 30 volts and 1 amp output. I think in order to get 30 volts of output from this board, that's 12 more volts than what I got. That would mean the transformer would have to be 40 volts, 38 volt transformer. So I'm not sure that this board is worth anything, because the LM317 is basically current limiting at 1 or 1.5 amps. I think it'd be much better just to build a LM317 power supply. Well, food for thought. I will tabulate this stuff, PDF, all of this, and put it in the subdirectory listed at the bottom of in the video description. Well, thanks for watching.